Hello everyone, I am Haley Gupta and my partner Dharmik today would be presenting in front of you the SASE design of electric vehicle. Before going to the presentation, we would like to give you an overview with this slide. Now we can jump on to the next slide, that is starting with what is a SASE. A SASE is a main frame of the car that provides workspace to all the subsequent to show their functionality and provide rollover cage to the driver and other critical components. SASE is the major component of the car which protects the passengers during the accident. There are different types of chassis used in commercial and passenger vehicles and race cars. So let us go through four major type of chassis designs quickly. All those four being backbone, ladder, space frame, and monocoque. Now, starting with backbone, it is considered a strong tubular backbone, usually rectangular in cross section, that connects the front and the rear suspension attachment areas. A body is then placed on this structure. You can see it in the figure uh, on the slide. Some cars also use a backbone as a part of the chassis to strengthen it. Examples include the Volkswagen Beetle, where the transmission tunnel forms a backbone. Now coming to ladder. One of the oldest chassis, the ladder chassis gets its name from the very own shape ladder. It has two long and a heavy beams which are supported by two short beams. The selling point of the ladder chassis was how easy it was to manufacture. During the beginning of the era of the automobile, technology was not really advanced, and the simplicity of the ladder chassis itself made it easier to mass produce. The chassis also makes the car assembly easier. The ladder chassis is quite heavy and thus finds its use in vehicles that need to tow heavy stuff around. Now coming to space frame. In space frame chassis, the suspension, engine and body panel are attached to a skeleton frame of tubes, and the body panels have little or no structural function. All members are triangulated. Now coming to monocoque, that was the last chassis we're talking in this slide. Monocoque being French for single shell or a single hull, it's the was the firstly used during manufacturing of ships and airplanes. It took quite some time to figure out that they can be used in cars as well. A monocoque is a shell around the car made by using both chassis as the frame in a single construction.
In this presentation, we'll be covering the design of a space frame chassis of a Formula Student electric race car. These are the single-seater, open-wheel race cars with the objective to be best in performance, faster accelerating, easily maneuverable, and safe. We'll be covering the goals and objective, design flow, constraints, CAD modeling, manufacturing testing part of the chassis, and at last, we'll be going through a brief overview of future chassis, that is carbon fiber monocoque. Primary goal of the chassis design is to accommodate all the subsystems and provide triangulation structure to protect them from impact. In order to achieve this, there are two major parameters which becomes very critical: stiffness and weight. Chassis is the member which absorb all the loads coming from the road via suspension linkages. Torsional stiffness of the chassis is one of the major parameters which determines a vehicle's safety as well as performance. Torsional stiffness of a race car chassis is in the range of 2500 to 3200 Newton meter per degree, owing to the increased suspension road stiffness. Reduced weight is a general goal of every vehicle which heavily affects the performance of a vehicle. Specifically in electric vehicles, in order to achieve higher range with the same battery size, it is very crucial to have a lightweight vehicle. And here comes the trade-off between weight and stiffness, making the goal of achieving an optimum weight without compromising the strength or the stiffness. Some goals specific to race car chassis include easy assembly and disassembly of all the major components and systems, such as battery, motors, controllers, drivetrain, etc. Ergonomic race car chassis should be ergonomically preferable for all the potential drivers, providing a wide view to avoid cones and other debris on the track. So this is what a design flow chart of a race car chassis look like. Triangulation and safety. Besides being a separate department, all the other systems beside the chassis design, mainly suspension. Hard points or suspension points are the points from where the road loads will be coming to chassis via suspension system. It becomes the goal to achieve suspension points on node location where more than 3 chassis members are being joined together to ensure the proper load path and avoid chassis tubes going into bending. For tractor system components, the goal is to accommodate within the TS protection structure to protect them from any kind of crash or side impact or even the contact during the rollover. For driver safety, 2 roll hoops, namely front hoop and main hoop, are designed in a way that in case of rollover, those are the contact point to the road, protecting the person sitting inside it and distributing the load in the chassis members in tension and compression to avoid getting into the contact with the driver. Weight and rigidity. In order to achieve a desired vehicle stiffness, there should be sufficient member with appropriate dimensions and stiffness welded together forming the chassis. But just increasing the chassis stiffness to infinite is not the goal, because after a certain range, increase in stiffness will less affect the overall stiffness of the vehicle, due to which the weight will be a critical parameter to consider. As shown in the graph, there is a sweet spot which helps deciding the stiffness and weight goals for the specific chassis.
To design a thing, making a CAD model and running simulation is only half of the complete process. The material used for construction of this chassis is usually carbon steel, but it is also becoming more commonplace that they are made up of aluminum alloys, considering its lightweight characteristics. For our car, we chose stick welding over MIG welding, owing to the parameters like accuracy, better quality, and aesthetics. This is the decision matrix for the same as shown. Moreover, some basic welding ideologies were implemented to reduce the deformation and local heating during welding. Before welding, we have to prepare welding fixtures to ensure the accurate position of all the members, brackets, nodes, etc. The images shown here are the fixtures designs manufactured from MDF and MS sheets using manufacturing processes like CNC milling, laser cutting, water jet cutting, and fastened together. In industries as large scale, these methods differ from a race car vehicle, but flow stays the same, followed by heat treatment and surface protection processes. Now coming to testing. In industries, we have 3 major kinds of testing that needs to be done. We have crash test, rollover test performed over the vehicles to test the chassis. For a race car, to validate the torsional stiffness of a chassis, stiffness tests are performed on a vehicle.
Coming to the future chassis, composite materials being widely used in aerospace applications now are making their way in automotive industries. Motorsport became the first one to use chassis made up of CFRP, that is carbon fiber reinforced plastic. It was first used by McLaren F1 in 1981. Carbon monocoques are constructed using the layers of carbon fabric, sandwiching the core panels made up of aluminum, honeycomb, balsa wood, etc., depending upon the requirements. The major benefit of the monocoque is its higher stiffness to weight ratio as compared to other types of the chassis. Recently, a company named Rimac Automobili has developed the fastest running electric car Nevera with the acceleration of 0 to 100 just below 2 seconds. Beneath its skin lies a carbon fiber monocoque with bonded carbon roof, integrated structure, battery pack, and rear carbon subframe. Nevera's structural core is lightweight, powerful, and extremely strong. Major automotive giant companies are shifting to CFRP monocoque chassis nowadays.
Hello, In this part of the presentation, I'll be showing you the space frame chassis which we built for our Formula Electric race car. So this chassis is made up of carbon steel tubes welded together to form the structure. This is called the front bulkhead where the impact attenuator is being attached. These are all the chassis members. This is the node location where we prefer to give suspension points as wheel loads coming from the wheel or road surface will be applicable to these points. Moving to the hoops, we have two roll hoops. This is the front roll hoop and this is main hoop we call it. So in case of rollover of the chassis, these points going to be the points where chassis will be touched to ground and which in turn ensures that driver is protected well within the structure even in the case of rollover. So this is where driver is going to be and his legs will be coming here. So this is the side impact structure SIS where which protects driver from any kind of side impact, and we have used higher outer diameter tubes to ensure its safety to basically increase the strength and stiffness in return. So this is the area where our accumulator, battery pack, motor controllers and motors are mounted. These are called the tractive system components. So this region is called TS protection structure, which protects all the TS components in the case of any accident or crash. So this is the rear bulkhead and this is what we call bodyworks. So these structures are made up of carbon fibers and glass fiber sandwiching a core. So basically this protects all the systems from rain, dust, debris. So this is what with which we cover the whole body of our chassis. And yes, this was the brief overview of our race car chassis. Thank you.
This was all from our side on SASE design of an electric vehicle. Hope you liked the presentation. Thank you.